Imagine pouring all your hard work, planting, growing, harvesting, into beautiful green fields, only to lose a large chunk of it to spoilage inside the silo. It's not just frustrating, it's costly for any dairy farmer. But what if you could predict and prevent these losses before they even start? That's where laboratory testing becomes your best ally. Using modern lab tests, we can unlock the hidden story inside our silage, measuring how efficiently it fermented, how stable it will be when exposed to air, and whether it will deliver the maximum nutrition to your cows. Dairy farmers today have more tools than ever to protect their forage, their herds, and their profits. Let's dive deeper into how lab tests work their magic, and why you should never store or feed forage blind. High-quality forage is the backbone of a successful dairy operation. Proper fermentation during ensiling preserves nutrients, enhances palatability, and reduces spoilage risks. Laboratory testing offers a scientific health check of your forage, telling you if the fermentation went right and whether the feed will stay fresh and safe over time. When we ignore lab testing, we gamble with cow health, milk production, and feed costs. When we embrace it, we manage risk, optimize nutrition, and make smart management decisions. Several lab measurements are critical indicators of fermentation success and forage stability. pH measures acidity level. A low pH, 4.0 for corn silage, shows proper fermentation and preservation. Lactic acid is the main fermentation acid. Higher lactic acid equals efficient, stable fermentation. Target a high lactic acid to acetic acid ratio, 3.1. Acetic acid is a secondary fermentation acid. Moderate levels improve aerobic stability, while very high levels may suggest spoilage. Butyric acid is a marker of clostridial spoilage. It should be near zero, as high levels mean disaster, poor quality, unpalatable silage. Ethanol is alcohol produced by yeasts. Excess, 2-3% DM, signals yeast problems and poor stability when exposed to air. Ammonia N, NH3N, indicates protein breakdown. High ammonia, 10% of total N, indicates protein degradation and poor preservation. Water-soluble carbohydrates, WSC, measure sugar availability. They are essential for efficient lactic acid fermentation, and low levels mean fermentation struggles. In addition to chemical analysis, labs can also measure aerobic stability, the silage's ability to resist heating and spoilage once exposed to oxygen. In a typical test, a silage sample is exposed to air and temperature is monitored. If the sample heats up more than 2 to 3 degrees Celsius above ambient temperature, instability is confirmed. Poor aerobic stability can lead to massive nutrient losses within days of opening a bunker or silo. Top dairy farmers don't just test, they act on the results. Here's how smart use of lab data improves forage management. Early problem detection allows you to spot risky silage before it affects cows. Improved storage helps you learn and apply better harvesting, packing, and sealing techniques. Nutrition optimization enables you to fine-tune rations for maximum milk yield and cow health. Better future silage allows you to choose appropriate inoculants and harvesting strategies based on real data. Always use certified forage labs and work closely with your nutritionist to make the most of the information. Think of forage testing as a powerful crystal ball, not just showing you what happened, but guiding what comes next. Every silage pit, bunker, or bag holds tremendous value, and a simple lab analysis can be the difference between a profitable feeding season and one full of losses. Today's dairy farmers have a clear advantage. Why guess about your forage when you can know? Harness the science. Protect your investment. Feed your cows better. Because great milk starts with great forage, and great forage starts with smart testing.